Alright, so first thing we do, come back, turn the breaker on. You look down here, you can see we got the transformer to take our 223 phase up to 400. You see we got 240 going in, which is good. 404 coming out. Then we boot up the machine. All right, let's see, the machine's booted up. I generally take a quick look in here just to make sure there's not something left from the day before. Before I do the spindle warm-up cycle, everything looks good there. Bring her out of e-stop, file manager, spindle warm-up, do the daily warm-up, hit execute, put her in auto mode, cycle start. It's going to do a tool change. Back to tool number 1, which is a 1/8 inch. And there we go. All right, I'll bring you back after this is done. So I made some changes to the file that I was running yesterday, and I'm gonna go ahead and update that while it's doing the warm-up cycle. So we're going to file manager here. I'm gonna do a file transfer, file import. File is right here. Only one on the jump drive, so we're going to select that. We're going to do a window select, which is going to bring it over to the right hand side. The folder that this is in is that 1919 bolt. So we hit enter, and the file we're replacing is that number 5 down there. So we'll go ahead and hit copy. It's going to say, hey, this file already exists. You want to overwrite it? Yes, we do. Exit back out. We can then select the file, and if we want, we can go in and look at the simulation of it. It reads through the file, make sure that there's no syntax errors or any problems with it. It does that once, and then it'll pop up the simulation view. I don't always look at it. I made some changes where you could see it in the simulation view. I sometimes check it out to make sure, just for a sanity check. So the yellow, that's your work coordinates. You can see I got a facing operation, and you can see it loading the whole sim then. So once the warm-up cycle is done, we can go back to that screen. Once the warm-up cycle is done, I got to change some tools out. My 1/4 inch is wore out, needs to be changed. My chamfering tool, the tip's broke, so I want to change that out. We'll show how to do that, and then we'll come back and we'll run this part. So we'll see you after the warm-up cycle. All right, you can see our spindle warm-up cycle is complete. So like I said before, I need to change out a couple of tools before we can start running today. So we'll do that first. So we're going to do an MDI input. And you can see we're at the MDI screen. I don't want tool 7, I need tool 3, so we're going to have to change that. This is a little bit hard to do with the camera, but so we're going to change that to tool 3, hit OK, Hit cycle start. Of course, the door's not locked, so let's clear that alarm. Cycle start, and then we can open this up in the middle of it so you guys can see. So, put tool 1 back. Grabbing tool 3. All right, so let me set this camera down, and hopefully you guys can see this. I don't get in the way. I mean, it's not that big of a deal. We're just pulling a tool out, but so you have to be here. Let me bring this over here. So you have to be in one of these modes: jog, incremental jog, or MPG mode. Sorry, I didn't even show you. Jog, incremental jog, or MPG mode to be able to actuate the tool release. So MPG, set this back down. I'll try to stay out of the way. I'm pretty sure I didn't, but there's the tool. And I'm going to change that out, and then we'll put it back in, and then we'll measure the length. All right, I got the tool swapped out. It's back into the spindle. And we're going to use the tool setter down here. Let's see if I can pan this down to set the tool length. Now there's 2 ways of doing it. It comes with macros and to set the tool length. Also, back this out a little bit. There we go. Also, there's a built-in tool length program, and we'll do that one first, right? So you're gonna go to work offset, tool offsets. Here's our work offset screen. Tool tip measure. Right, that's the screen that comes up. This is tool 3, so we're gonna just arrow over and change that to 3, obviously. Enter. We have to have the door closed to get it started. Has to be in auto mode. And we hit start. And you see it's, sorry. All this handheld stuff's gonna make this look awful. So it'll go down and touch off 3 times to measure the length. All right, so that's it for that tool. Let's see if I can get this thing to, there it goes. So if we go back, to our offset screen, we can go to tool set and it'll bring up our tool links, right? So that's tool number 3. So it says it's 2-inch, 754 9/10 is the length. So we're gonna change that just for fun here. And we're gonna set that to, let's just say 2. Hit enter. Well, 2/10. It's an awful short tool. And then we're gonna use the macros that come with the machine to set the tool length. So we're going to File Manager. And then if you see in this folder, and these come with the machine, we've got the inch TTC. So hit enter, and there's 4 files here. So 2 of them are calibrations to set the diameter and the length, and then we have diameter measure and then length measure. So obviously we're not going to do the diameter, especially with that little shield on there. So we hit execute, and that brings up the macro that will measure the length. So let's go ahead and run that. Oh, what we did was we forgot to change it to tool 3. So we'll stop it here. So reset. So we're gonna go to edit, and So it's saying it's tool 7, but we actually want tool 3. We should have done this in the first place, but oops. Backspace, 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 tool 3. So it's going to change it to tool 3, and we want the offsets in the table written to tool 3, so we need to change that. And our diameter is already at 250, so we're good to go there. So now we can execute that. Now you can see it's going to do a tool change back to tool number 3, run the macro, set the length in tool number 3 spot. So back in auto mode, cycle start. And this actually does it a little different than the tool setter, the automatic tool setter page. It takes 2 readings instead of 3. Hopefully you guys can see that in there. I know it's kind of boring, but all right, so let's go back to the, so you can see they are a little different. In you know, you run it a couple times in a row and it always gives you a couple tenths off. So we're not too far off, so we can call that good. And let me get this set up and we'll go on to the next spot. All right, so I got both of the tools swapped out and measured. And the next step is going to be to set our work coordinates up. So I'm going to try to do this so you guys can see it. It's going to be a lot of moving around one-handed, but so what we're going to do is we're going to go back to this screen, right? And here's all your coordinates: G54, 55, 56, whatever. You can see we're in G54. We're going to set the workpiece coordinates. So we're going to set X first. Hopefully you can see all that screen. X first. And we got our tool setter in here. Zoom in on this a little bit. Let's see here if I can make this thing do what I want it to do. There we go. All right, so we're gonna just bring this up to the edge of the piece because we're doing excuse me, X first. We're shot there a little bit. I know it's like a tenth, but it bugs me. Okay, so that's the edge of the part. I'll zoom in a little more on that for you guys so maybe you can see it, how that works, right? So let's back that out. You can see the 2 dials are 0. Right, that's your goal, is for the edge of the part. And we're moving it just a tenth at a time. Alright, so that's it. Let's zoom back out over to here, right? There we go. Alright, so that's X. So what we're going to do is we're going to apply machine coordinates. Do you want to do it? Yep. And now you can see it's set. So it's not too far off from the part that was just in there. So now we're going to do Y. Back over here. So we'll back that. Here, let me zoom in for you. Not quite that much. That looks good enough. Alright, so we're going to bring that back away from the part. And then bring it over so we can do the Y. And it's essentially the same thing. Now that in a little bit closer. There we go. Now I'll come back over here. So now you can see we got Y highlighted. And then again, right here, just apply machine coordinates. Yep. And then you can see it changes to Y, right? So Z is next. So on this part, the bottom of the part is where the Z is. Sorry, let's get this zoomed in. The bottom of the part is where the Z is measured, and you can see I have the parallel sticking out a little bit. Normally I wouldn't do that, but it'd be much easier for you guys to see what's going on by doing that. So that's the reason why. So let's back this off. So now we're off the edge of the part. Move this over. Hopefully you guys can see that. I know the lighting's not great. Alright, so we got it kind of over our parallel, and then again it's just the same procedure. Bring it down until it reads 0. And we'll come over here. Back this out so you can see it. And then we're going to hit apply machine coordinates. Yes, we want to apply it. So you can see it applied the 8.7990. But we need to factor in the distance. We need to factor in the distance from the face of the spindle to where that probe is, and it reads 0. And you can see I have that written, it written right on the tool holder itself, right? So if we go back over here, we're going to do an incremental input, right? So we're going to put a minus, so if you guys can see this, minus 8.01134. Incremental input, yes, we want to apply it, and then there's our distance, 16.8103. Right? So now we can bring that up. And so now we know, zoom this in again. Right, so we know our XY is right here at this edge. And the reason I did that is because of the way the model is, and this has been machined on this side. So normally you use the upper left-hand corner or maybe the center of the part. So if we did it right, our XY should be right there and our Z should be at the bottom of the part. So you can check that. Let's close this up real quick. So we can go back to our MDI and do an MDI input. So let's delete this out. Let's see here. So we're going to do a G0, X0, Y0. Hit OK. And that should rapid us over to where our XY coordinates are. So obviously raise it up out of the way. You know, whatever you have in there, if it's an edge finder or a, 3D taster like what these are. Let's see if we can get in there. And then we'll hit the cycle start button. And it sure looks like that's right in the corner. And for off a few thousandths you wouldn't know, but if you type something completely wrong or did something wrong, you'll know it's there. Alright, so the next step, our next step is to, we want to load our program. Zoom this out. Obviously we want to take our tool out, but we'll load the program in first so we can go back, File Manager, back to the main screen, 1919 bolt. We're on op number 5, so we can select that. And then put it in auto mode and hit execute. And then it'll bring up the monitor screen, and there's our file. Over here, it's going to be a simulation. You got a couple of things you can change around in here if you're interested. This is like the part count screen. Here's your loads, and then here's just back to your standard screen. So let me set this down for a second, and we'll get it loaded, and then we'll get the part running. Of course, obviously, once it's running, you won't be able to see anything because of the coolant, but let's see what we can do. I'll bring you back in a second. All right, so I went ahead and single blocked this off camera just to verify, the heights and whatnot. So I know you're not going to be able to see much here, but we'll fire it up. Once the coolant gets flying on the screen, you won't see anything, but we'll fast forward through it, if it's too much of a nightmare. So at this point, you saw the program's loaded, single blocked it, heights look good, hit the cycle start button, and we are good to go. All right, I know that video was horrible because of the coolant, but see our part there. One more op to go on that and it'll be done. I got a couple more that I gotta run, and I'll run after that. You can see we're back to the front, or the start line. From here, just throw another one in. Do the exact same thing, and just keep going until they're all done. So hopefully that helps some people out. I had a guy request if we could do something similar to this, so that's kind of why that's why I did it with this part, because it was just the one op and it would be quick to do. So hopefully it helps. We'll see you guys on the next one. Thanks for watching. If you like it, hit the like button and subscribe. Well, one more thing here, guys. I thought I'd give you a close-up. Hopefully this is focusing. It's hard for me to see, but so that's that's the bottom side of this part. There's the top, left-hand side. This side is the next operation that we got to complete, but couldn't be happier with the machine. The finish is beautiful, very accurate, certainly accurate for the stuff that we make. So anyways, thought I'd give you a shot of that. See you on the next one.